Hello, my dear students. Hope you all are well at your place. Today, in this class, I'm going to discuss about the Newton law of motion. Newton, a very famous physicist, a well-known personality to whom each and everybody knows. Newton has given a law in various fields like in a gravitation, like for the motion, he has given a certain law. Today we are going to discuss about the Newton law of motion. For the motion on a straight line or in a plane, Newton has suggested few laws. Altogether, Newton has given three laws, which is named as Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. All the law is having their own individuality, and they were dealing with a certain different topics. So let's just start with the Newton's first law of motion. Newton's first law of motion. According to the Newton's first law of motion, if the body is in rest, it will remain in rest, and if the body is in motion, it will remain in motion until and unless an external force is applied on it. Suppose, what he wants to say, suppose if the body is in rest, you have kept any of the ball in a rest position, it will remain continue in the rest position only. And suppose if any of the person is riding a bicycle, it will continue in the state of motion only until and unless any external forces applied on it. Suppose you is riding a bicycle, it will remain in a motion only until and unless you will not apply brake on it. As soon as you applied as brake is what? Brake is a kind of external force over here. Then the bicycle it is stopped. Similarly, you can take the example of a ball. Suppose a ball is kept in a position of rest. It will remain in a position of rest only. But when you apply a kick on it, that means you are applying an external force on it. In such a state, the ball changes its state from rest to motion. This is all about the Newton's first law of motion, that the body it will not change its state until and unless an external force is applied on it. So many examples are there. Body, and now the question it arises in the mind why the body did not change its state by themselves only. If the body is in rest, why without any force it is not converted into the state of motion? Majority of the students were thinking about this. Okay, so for this question, the answer is inertia. What inertia is? Inertia is the inherent property of the body. It is an inherent property of the body which stops the body to change its state. It does not allow the body to change it itself by ourselves. And hence, the first law is also known as law of inertia. Now let's discuss about the second law of motion. What is second law of motion? Newton has suggested that the momentum of the body it changes with respect to the time. The momentum of the body it changes with respect to the time, and it is directly proportional to the force applied on it. Whatever the momentum of the body changes, it is according to the force, that how much force we are applying on it and in which direction. Suppose I am applying a force on this direction, then the momentum of the body also changes in that direction only. That means the rate of change of momentum is directly proportional to the force applied on a body and in the same direction. So, according to the statement, force is directly proportional to rate of change in momentum. That means F directly proportional to. Now the question came, what is change in momentum? As change defines that final minus initial. Whatever is the final state of the body and the initial state of the body, you subtract both of them and you got the changes. So here also the change in momentum means final momentum minus initial momentum. Now, what is the formula for final momentum? It is mv. What is the formula for initial momentum? mu. So it becomes f directly proportional to mv minus mu upon t. Taking m as a common, it remains f directly proportional to m v minus u upon t. Now we all know very well that v minus u, that means final velocity minus initial velocity with respect to time, is known as acceleration. That means the rate of change of velocity is known as a acceleration. So here we replace v minus u upon 2t by a. So f directly proportional to ma. Now you all are very well known that while changing the proportionality sign, we need to put a constant. Here that constant is k. So f equals to kma, where the value of k is equals to 1. Keeping the value of k equals to 1, f equals to ma. So hence we got a formula of force from the Newton's second law of motion, that force is a product of mass and acceleration. Since the second law deals with the word momentum, and hence the second law is also known as the law of momentum. Now proceeding towards the third law. What is Newton's third law of motion? According to the Newton's third law of motion, it is very simple phenomenon which is majorly existing in a universe, that to every action there is equal and opposite reaction. Whatever you are performing, you are getting it back. This is the Newton's third law of motion. Whatever will be your action, the reaction of the other side will be accordingly. If you, for example, if you are wearing a sketching and you are moving toward the wall, so you are putting a pressure on a wall, and in return the wall push you back. That means you have done your action and equal and opposite reaction was done by the wall. So this is the Newton's third law of motion. Since it deals with the action and reaction, and hence the third law is also known as a law of action and reaction. So in this manner, Newton has given a three law. First law of motion is known as law of inertia, second law of motion is known as law of momentum, and third law is known as a law of reaction and action. I hope Newton's law is clear to you all. Stay tuned for the further topic. Thank you so much. Stay healthy, stay well.